Hey everybody, so here's notes 5-2 and we're going to make a flip book. So you fold your paper in half and cut along these lines inside to make sure you can see the different properties and the rules that they have. Alright, so first we're going to talk about the product of a power. So the word product implies that there's some kind of multiplication happening, and a power represents that there's some kind of an exponent involved. So when we look at our two examples, here's our Algebra 1 conversation. Every time we have the same base, we go ahead and we add the exponents. So this is going to be equal to a to the m plus n. Keep in mind that the exponents are being added, but these are actually factors of a term, things that are being multiplied together. All right, so that's the Algebra 1 idea, but when we come over to this side, we can see, okay, now we know we're in Algebra 2 because I've got rational exponents, fractions. So I know that my result is going to be p to the 1/8 plus 4/8 power. Reminder of adding fractions. When we add fractions, we need to make sure that we have a common denominator. So good news, we're in luck. So p is going to be to the 5/8. Remember, common denominator, and you add only the numerators, which is that top number. Don't forget to check out whether or not it's a fraction that you might need to simplify. All right, so that is going to be our product of powers. I have a power of a power. A power is going to be an exponent of an exponent. And these are the ones that are very powerful because I have the word power and power twice. So one way to remember that is that a power of a power is very powerful. All right, so when we open up this example, my Algebra 1 rule is a to the m times or to the nth power. So this exponent is going to be multiplied, so I wind up with a to the m times n, and I can write that as a to the m n. When I come over here and I look at a rational exponent problem, my d is going to be to the 1/4 times 2/3. My favorite little poem is multiplying fractions is no problem. Top times top, bottom times bottom, which is going to give me 2/12. Keep in mind you need to simplify, so this is going to become d to the 1/6 power. Now, if you're a person who likes to simplify before you multiply, you can see that when I look above and below the fraction bar, if I see a common factor, I can divide that out first. So you either simplify here at this point, or you can simplify up here, giving me then 1 times 1 is 1, and 2 times 3 is 6. All right, when we talk about the power of a product property, now we're talking about power, which means we have some kind of exponent, and then of a product, so there's going to be some kind of multiplication inside of that. So here is my product, a times b, and my power, m, is to that power. Now, this feels like the distributive property, but we don't say distribute because that's when it's a plus b. But instead, we're going to tell you to share the power to each factor. And if I share the power, to each factor, I wind up with a to the m times b to the m. This is considered simplified because I removed my parentheses. All right, so when I come over here, this Algebra 2 application of that rule, 1/2 is going to be shared to 25 and to x. Keep in mind, these are two different factors inside this one term. So that's going to make 25 to the 1/2 power and x to the third times the 1/2 power. So we bring back into this rule our power of a power when I use multiplication to go ahead and simplify. Now when I go to simplify, 25 to the 1/2 power is 5. And x to the third to the 1/2 power, multiplying fractions is no problem. Top times top, bottom times bottom is going to give me x to the 3/2 power. I'm not going to bother simplifying that because that improper fraction does not divide evenly. All right, now let's talk about our next property, which is our negative exponent property. In Algebra 1, we learned that anything has a negative exponent. This negative exponent is a way of showing division. So we end up with 1 over a to the m. We are dividing by a m times. Now, remember, if I had something in the denominator, that would move it up to the numerator. So basically, anytime you see that negative exponent, you're going to move to either denominator goes to numerator or numerator goes to denominator. All right, let's look at the Algebra 2 application of that idea. Now keep in mind, this 12 is a separate factor. He's not affected by the negative exponent, so he's going to stay where he is. Our whole numbers can be written as a numerator over 1. This entire fraction is negative. Remember, if I have negative 2 divided by 5, that's the same as 2 divided by negative 5, which is the same as the opposite of 2/5. No matter what, this exponent is negative. So my variable with that entire exponent is going to be moved down to my denominator. All right, my quotient of powers is going to be similar. It's going to feel similar to my product of powers, except I'm dividing, and because I'm dividing, I'm now subtracting my exponents. So this becomes a to the m minus n power. Now that's always relatively simple. For example, if I had, let's say I had 5 to the third over 5 squared. I know that that's 1, 2, 3 5s divided by 1, 2 5s. We can see why we're subtracting, because they cancel out, and that's how I end up with just 1. But it's a little more complicated when I'm looking at my Algebra 2 application. So it's easier for me, instead of drawing out this, to remember the rule. So it's going to be 32 to the 4/5 power, and that's going to be divided by 32 to the 1/5 power, which means I wind up with 32 to the 4/5 minus 1/5 power, which is going to give me 32 to the 3/5 power. Are you ready for this? We can simplify that, because I know that the 5th root of 32 is going to be 2. So guess what that means? That's the same as 2 to the third, which is the same as 8. How about that for complicated? All right. For our last one, we have the powers of a quotient property. And the power of a quotient property is going to be, again, that idea of sharing. This exponent is going to be shared to both my numerator and my denominator, giving me a to the m over b to the m. Oops, I forgot to change colors. We'll go ahead and make this one dark blue. A to the m and b to the m. We'll stick with the light blue. Alright, so that's the same as x to the 1/3 over 27 to the 1/3, which is going to be the same as x to the 1/3 over 3, because the cube root of 27 is going to be 3. Alright, good job. Now it's time to do the activity and the practice.